We are now going to go through the identification of a limiting reagent in a reaction process. And the idea of limiting reagents is many times when one performs a reaction, we purposely have one of the reactants in excess and the other one limiting reagent. Now the reason why we'd have one of them in excess is that that tends to optimize our product yield. So let's go ahead and let's look at the Haber process in which we have nitrogen reacting with hydrogen, producing ammonia. All right, so we're going to go ahead and we are going to add 1 mole of nitrogen with 5 moles of hydrogen. And what we would like to identify is which one is the limiting reagent and which one is in excess. So the idea of the limiting reagent is all stoichiometric calculations towards a product will be based on the limiting reagent. Once the limiting reagent is consumed, the reaction stops. You can't have reactant A producing products if there isn't any more remaining reactant B. And it will be the limiting reagent that dictates the amount of product once consumed. So if we have 1 mole of nitrogen and 5 moles of hydrogen, we would like to identify which one's the limiting reagent. So we say here, if we have 1 mole of nitrogen, how many moles of hydrogen is required for it to fully react? And to identify that, we look at the balanced stoichiometric chemical sentence, and we have a 1:3 ratio in the balanced chemical sentence. So how many moles of hydrogen is required to react with 1 mole of nitrogen? We would agree that we would need 3 moles of hydrogen based on the 1:3 ratio. We see that we have, how many moles of hydrogen do we have in this particular problem? We have 5 moles of hydrogen. So we have more hydrogen than we need. In fact, we have excess moles of hydrogen. And how many excess moles do we have? It would be 3 minus the 5, and we have 2 moles of excess H2. So what we identify from that is that nitrogen is our limiting reagent, and all stoichiometric calculations of the product will be based on the limiting reagent. Once all the nitrogen is consumed, we do have the excess moles of hydrogen, 2 moles, but it will not be able to produce any more product due to the nitrogen having been totally reacted. Okay, so let's go ahead and do this again. And we're going to go ahead now and just change, instead of we're going to double the moles of nitrogen and leave the moles of hydrogen at 5 and see in this case which one would be our limiting reagent. So let's go ahead and write down. So now we're going to have nitrogen, once again reacting with hydrogen, producing ammonia. Okay, and we're going to have, in this case, we're going to have 2 moles, react 2 moles of nitrogen and leave the hydrogen at 5 moles of hydrogen. So now which one is the limiting reagent? And it's not always obvious based on the stoichiometric relationship of, in this case, the 1:3. So we can ask ourselves, okay, moles of H2 required to fully react all N2. Okay, so we do want to write down our stoichiometric relationship based on the balanced chemical sentence, in which we have 1 mole of N2 reacting with 3 moles of H2. All right, so the moles of H2 required to fully react all the N2, well, we have 2 moles of N2, place it over 1, and we have our 1:3 ratio. which we would have 3 moles of H2 required to react with 1 mole of N2 based on the balanced chemical sentence. All right, so with that, we identify how many moles of H2 would be required to fully react 2 moles of N2. It would require 6 moles of H2. And then we reflect back, okay, how many moles do we have of H2? We only have 5 moles in this instance, so we do not have enough H2 to completely react all the N2, and therefore H2 is the limiting reagent. And all stoichiometric calculations of the product will be based on hydrogen. One could ask, so we've identified which one is the limiting and then N2 is in excess. We could then ask, okay, well, how much excess N2 do we have? So we come back over here and we say, okay, come back over here and let's go ahead and do that analysis, which is, okay, how much N2 reacts with 5 moles of H2? Okay, so we're asking here, moles of N2 required, just kind of reverse our question, to react all H2. And that will identify how much excess. So we're going to go, okay, moles of N2 equals, well, we have 5 moles of H2. Place it over 1. We have our 1:3 ratio, where we have 1 mole of N2 for every 3 moles of H2. And so how many moles of N2 will react with all the H2? 1.67. So 1.67 moles of N2 will fully react. How much do we have? We had 2 moles of N2, so we can go ahead and identify excess moles of N2 equals 2 minus the 1.67 moles, and the amount of excess that we have is 0.33 moles of excess N2. And that would be a limiting reagent calculation and analysis.